As you have already studied acceptance sampling and the different types of acceptance sampling plans we have already discussed. Now during the next two sessions I will be concentrating on a number of the representative numerical exercises on acceptance sampling, as well as some other aspects of quality design and control, like say the reliability, like say process capability analysis, as well as the Taguchi method. So during this particular session on acceptance sampling, I will be discussing a few typical numerical exercises specifically on acceptance sampling. And as you know that there are the two main types of acceptance sampling. One is the attribute sampling and the second one is the variable sampling. So let us first concentrate on a few problems on say the variable sampling plan. Now the first there will be 8 exercises in this session, and one by one I will be discussing all these exercises. In the first exercise, let me read out the problem. Suppose it is desired to set up a sampling plan for thin walled cylinders based on tensile strength. That means it's a variable sampling plan. The lower specification limit is 170 psi. The sampling plan should have the characteristic such that a lot will be accepted with a probability of 0.95 if it contains 1% defective, and will be rejected with a probability of 90 if it contains 10% defective. Okay, so that means here the acceptance sampling plan which you are going to design, the main purpose of such a plan is to control the proportion non-conforming. The standard deviation is known to be 10 psi. That means it is a known standard deviation case. This particular case we have already discussed. Now what is the solution? The solution is here a good quality is given by the proportion non-conforming, that is 1%, that means P1 is 0.01. A bad quality is specified as 10% non-conforming, and so the value of P2 is 0.10. You please refer to the derived the sampling plans, that means the derived expressions for the parameter values or the parameters of the variable sampling plan. The value of alpha, that is the producer's risk, is 0.05 and value of beta is 0.10. Now when you refer to the standard normal deviate or the standard normal table, what you find that the capital Z1 against P1, okay, that means area under the curve beyond the Z1 that you have to compute. And first you compute Z1, okay, you apply the formula, you will get a value of 2.327. Similarly, against P2 you compute the value of Z2, and Z2 value is 1.282. And similarly we have a formula for Z alpha, and that is 1.645, and similarly the Z beta value is 1.282, that is against the tail area of 0.10. Now you have an expression for n, that is the sample size, and if you use that expression, ultimately you get a value of n as 7.845, and obviously the sample size must be an integer, so it is rounded up to 8. So sample size is 8, one of the parameters of such a sampling plan. Now as you are aware that there are two the methods you may apply, that is the form 1 method as well as the form 2 method for such for using such a sampling plan, variable sampling plan. Now here Obviously, under form 1 or the k method, you must get the value of k. So, keeping alpha at 0.05 level, already we have mentioned that the producer's risk is at say the 5%. So, you know the expression for k. So, what will be the value of k? So, value of k is 2.327 minus 1.645 divided by root over 7.845. So, the value of small k is 1.74. Now, if you use form 1, what do you do? First you compute ZL. Okay. So, ZL and you compute for a random sample of 8. Is it okay? So, how do you compute ZL? That is basically x bar minus capital L, that means that L capital is the lower specification limit divided by sigma. So, value of sigma is already given. When x bar is known, obviously you must get a sample of say of size 8, that means 8 values you will be getting, and you compute x bar. So, if and once you compute x bar, when capital L and sigma is known, you can compute ZL. Okay. So, if ZL is greater than or equals to 1.74, that is the value of k, we accept the lot, otherwise you reject the lot. Okay. If you move to form 2, what you need to do? That means first you compute the expression of small k into root over n by n minus 1. Is it okay? So, value of k is 1.74, the value of n is 8. So, the value of this expression is 1.86 for the given problem. Now, what do you do? Now, you refer to the area under the normal curve beyond say m equals to 0.0314. Is it okay? So, so this value you will get, that means 1.86, that means area under the normal curve that is beyond 1.86. Is it okay? So, that value you will get as 0.0314. So, that is the value for capital M, that means 3.14% is the maximum allowable proportion non-conforming. Now, you compute QL, that means it is an unbiased estimate of ZL, that means ZL must be multiplied with root over n upon n minus 1. So, you get the value of QL, and then you refer to the area under the normal curve, okay, say the beyond say the QL, and that area you get as p hat. Now, if p hat is less than equals to capital M, that is 0.0314, you accept the lot, otherwise you reject the lot. Is it okay? So, this is problem exercise number 1, and I am sure that you have understood all the steps. Now, let us move to exercise number 2. Suppose that a company would like to design a variable sampling plan for steel bars based on tensile strength with both an upper and lower acceptance limit. Is it okay? That means it is a two-sided specification limit case or the double specification limits case. So, this case already we have discussed. That means we have derived the corresponding say the formulae for determining say the parameter values. So, the company does not wish to accept steel bars with a tensile strength greater than 10,100 psi or lower than 9,900 psi more than 10% of the time. That means, from this expression, from this statement, you can make out that what will be the corresponding the probability of acceptance. That means, even if the quality is extremely poor, is it okay? That means, if it is greater than this, it is considered to be extremely poor. Similarly, if the value is less than 9,900, again it is considered to be extremely poor quality. So, against these two poor quality levels, what is the corresponding the probability of acceptance? That is 10%. That means, it is essentially a consumer risk. So, here X2L bar is 9900 and X2U bar is 10,100 and beta is equals to 0.10, that is the consumer risk. Suppose that x1 bar is 10,000. How do you get x1 bar? Usually, unless otherwise specified, you say that the midway between these two, that means x2 u bar and x2 l bar, the midway, that is considered to be x1 bar, and x1 bar is considered to be is assumed to be very good quality, for which the probability of acceptance is very high. Is it okay? So here the probability of acceptance is 0.95, and that's why the producer's risk alpha is 0.05, and the standard deviation is known to be 100 psi. That means it is the standard deviation known case. Now what do you do? We have already derived this the four expressions, like say this is 1.960, that means against a value of say 0.025, that is the tail area, you will get a value of z as 1.960. Okay, and similarly, say xu bar minus 10,000, this is 10,000 minus xl bar, this is xl bar minus 9900, and this is 10,100 minus this. So all these four expressions you have. So this is 1.960, this is minus 1.960, this is 1.645. You refer to the standard normal curve. Okay, so against those corresponding tail areas, you will get these values, and again this will be minus 164 values. 1645. Okay, so one is positive, second one is negative, third one is positive, fourth one is negative. So since the last equation can be derived from the other equations, not only the last one, you choose any three equations from this set of four equations, you will find that the fourth equation can be derived from say any three fourth equation, any three from the first three equations. So okay, so what you try to do, that means one equation is a dependent one, whereas the remaining three are independent. Okay, simultaneous equations. So what you do, you just select out of these four any three equations. So using the remaining three equations, and then you solve for xu bar, xl bar and n. So what is this is what is xu bar? That is the upper acceptance limit. What is xl bar? That is the lower acceptance limit, and n is the sample size. So here when you solve these three simultaneous equations, so you get a value of xu bar as 10,000, 10,054, xl bar as 9946, and n equals to 13. So in summary, the variable sampling plan is as follows: obtain a random sample of 13 steel bars from a lot, that is the sample size, and compute the average tensile strength, that means the actual value of x bar. That means 13 such values you will be getting. You compute the average value, and that is x bar. If the sample average is higher than this one, that means 10054 psi or lower than 9946 psi, reject the lot, otherwise you will accept it. Is it okay? So now let us move to exercise 3, and exercise 3 is related to a special kind of sampling plan. You know, we have mentioned that one of the special kinds of the special purpose sampling plans is the chain sampling plan, and the chain sampling plan you use when the sample size is very less than equals to 10, and if the sample size is less than equals to 10, why the sample size is less than equals to 10? Because there are many cases where inspection is done through destructive testing. So obviously the sample size should be as minimum as possible, and if the sample size is less, obviously the acceptance number is 0. So acceptance number will be 0, and here the third important variable is I equals to 2. Is it all right? So consider this chain sampling plan with n equals to 10, c equals to 0. This is a very special case, because if you use a single sampling plan with c equals to 0, as I have already mentioned, that then you get an OC curve, and OC curve will be a convex function, and it's very difficult to say the work with a sampling plan where the OC curve is a convex function. So you have to change the OC curve shape from a convex function to an inverted S. So n equals to 10, c equals to 0 and I equals to 2. So compute probability of acceptance at an incoming lot quality of 0.08, that is p equals to 0.08. So what do? That means this is the expression. That means what is the probability of acceptance? That if you do not find out of 10 any non-conforming unit, so you are going to accept it. You are again going to accept the lot. If you get out of 10 units inspected, 1 unit as non-conforming, provided that the last I number of the samples which you have drawn from the lot, okay, because you are dealing with a series of lots, not an isolated single lot, and you will find all the previous I number of the samples, you do not find any non-conforming unit. That's why it is 0, 10. Okay, so under this condition, you accept even if in the present sample, you find one non-conforming unit. So this is the probability of acceptance if out of 10 units you inspect, 0 found as non-conforming. So you assume Poisson the binomial distribution. So it is 10C0, 0.08 to the power 0, 1 minus 0.08, that is 0.92 to the power 10. 10 is n. So this is 0.434. And what is the probability that out of 10 units, 1 unit found as non-conforming, that is 10C1, 0.08, that is the incoming lot quality, to the power 1, 1 minus 0.08, that is 0.92 to the power n minus 1, that is 10 minus 1, that is 9, that is 0.43. This is maybe is different, its value is 0.63 something. Okay, so you just compute this value, it just cannot be 4.434. Is it okay? So hence probability of acceptance is actually this value is 0.378. Is it okay? So it is 0.378. So ultimately the probability of acceptance is 0.434 plus 0.378 plus 0.434 square equals to 0.505. Okay. So now you move to exercise 4. Consider a double sampling plan, okay, in attributes category. Now we refer to attribute sampling plan, and one particular say the type of sampling plan, that is the double sampling plan, and the double sampling plan is widely used. Okay. So here is an example of a double sampling plan. Is it okay? So the given lot size n equals to 2000, and what are the parameters? N1, that is the first sample size is 30. First acceptance number, that means acceptance number based on the first sample, that is C1, that is 1. Rejection number based on the first sample, that is 4. You already know what is the working of a double sampling plan. We have already explained. The second sample size is 60, that is N2 equals to 60. Then acceptance number of the combined sample, that is 3. Rejection number for the combined sample, that is 4. Compute PA1. What is PA1? That means the probability of acceptance based on the first sample. And what is PA? That means probability of acceptance or the total probability of acceptance for a given incoming lot quality P equals to 0.05. So how do you compute PA1? PA1 is say sigma say I equals to 0 to 1. Is it okay? So actually I equals to say 0 to C. So here as you consider the first sample size, the acceptance number is 1. That means either there could be 0 non-conforming unit or 1 non-conforming unit in the sample of size 30. Then only you are going to accept it based on the first sample. Now 30 Ci, okay, 0.05, that is P to the power I into 1 minus 0.05 to the power n minus I. Is it okay? So similarly Under what condition you go for PA2? That means when the number of non-conforming in the first sample is either 2 or 3, you have no other alternative but to go for say second sample, say second stage. That means for making a decisions you have to draw the second sample of size 60. So these conditions are mentioned. That means in the first sample size, that is a random variable based on the first sample size. So that is x1 equals to 2. You are going to draw the second sample, and in the second sample you may not get any say non-conforming unit, that is x2 equals to 0. And similarly, when x1 equals to 2 in the first sample, and so obviously in the second sample you may get so you must have just one non-conforming unit for the acceptance of the lot, or in the first sample you will find there are 3 non-conforming, and if you find 3 non-conforming and based on the second sample, suppose you are going to accept it, obviously in the second sample you must not have any non-conforming unit. So these are the conditions you must know, under which but the first then at the second stage you are going to accept the lot. So we have explored all those possibilities, and then what we are trying to do, that means we go for say Poisson approximation to binomial, and so you calculate all these individual probabilities, and then the total probability of acceptance based on the second sample, that is 0.0554. So these values already you can compute, either you can apply binomial distribution, or in many cases you go for Poisson approximation to binomial. Now you may consider several values of p, say from 0.01 to 0.15 in a step of 0.01. That means you are considering 15 such values, incoming lot qualities, possible incoming lot quality values, and compute PA1, PA2, PA. What is PA? PA is basically PA1 plus PA2 and PR1. That means probability of rejection based on the first sample for each value of P. Is it okay? So the values are plotted to form the OC curves. Is it okay? So this is an exercise you can carry on. So obviously you know that against a particular value of P, how can you compute the probability of acceptance, okay, either based on the first sample or the second sample, or say the total probability of acceptance based on the probability of rejection based on the first sample, and probability of rejection based on the second sample. Now let us move to the next exercise, exercise 5. Consider the single sampling plan. SSP stands for single sampling plan, where n equals to say 1000, small n equals to 45, c equals to 2. Is it okay? Suppose that the incoming product has a lot percent non-conforming of 1%. The probability that the lot will be accepted is 0.9896. Construct AOQ and ATI curves. We have already explained what is AOQ. Is it okay? And what is ATI. We have defined these two terms, and particularly these two terms are applicable. You have to define when you apply the rectifying inspection. So what is the solution? For constructing these curves, you need to consider a number of p values, say from 0.00. Okay, so if it is 0.00, obviously the probability of acceptance will be 1, right? So you can check it, and then you consider the 10 values in a step of 0.01. That means the first value will be 0.01, second value will be 0.02, third value will be 0.03, and so on. So for just I am giving you one example. That means against a particular value of p, say 0.10, that means this value, what will be the AOQ for a single sampling plan? PA into P into capital N minus N divided by capital N. We have already derived these expressions. And then what is the value of PA? PA is say 0.98, 0.15, say 0.9896, and P is 0.10, 0.959896, 0.10, and this is 1000 and n is 45 and capital is 1000. Is it okay? So, this value is 0.0152. Is it okay? So, AOQ value is this, and for p equals to 0.10 you calculate ATI. Again if you apply this formula, n into PA plus capital N into 1 minus PA, and so you apply you use these values and you get a value of say ATI, that is 54.93. Now, what you consider? You consider several values of P, and you, as I have already pointed out, that against a value of P equals to 0.00, that means the best possible quality. That means no non-conforming say non-conforming units in the lot. So, that is the incoming lot quality. Obviously, the probability of acceptance will be 1, right? And several other values you consider. For each such the values of P, you compute PA, and immediately you apply the formula for AOQ to get the values of AOQ. Now, you move to exercise 6, an item by item sequential sampling plan. So, again it is a special kind of sampling plan in attributes category we use. Now, an item by item sequential sampling plan is desired with producer's risk of 0.03 at AQL of 0.012 and the consumer risk of 0.08 at LQL of 0.063. Find the equations of acceptance and rejection lines. Okay, when we explained the sequential sampling plan, it is essentially a unit by unit or item by item say sampling plan, not lot by lot acceptance sampling plan. Okay, so explain the operation of the plan. So, alpha value is 0.03, P1 is 0.012, beta is 0.08, okay, and P2 is 0.063. So, these values must be specified. The parameters of the acceptance and rejection lines are calculated as follows. That means, what will be the expression for the K? Okay, so we apply the formula, you refer to that particular formula, you get a value of 1.712, and similarly this is basically for the acceptance line. What is the intercept? That is HA, and this is the expressions. Okay, so you use and you get a value of 1.458, and this is the intercept for the rejection line, that is HR. Okay, so this again you get the corresponding values, and you get the value of HR, that is 2.000, and so it is basically in terms of K, that is so everywhere you will find that it is divided by small k, and already you have computed the value of small k when P1 and P2 values are known, right. So, once you have all these values, and this is the S is the slope. So, slope component is also is a function of small k. So, you get the value of 0.031. So, now the acceptance line is this, is it okay, minus HA plus S into N, and the rejection line DR is again HR plus S into N. So, the cumulative number of non-conforming units is compared to the two lines. The lot is accepted if it plots on or below the acceptance line, and the rejected if it plots on or above the rejection line. So, that is the decision rule. If it plots in between the two lines, that means it is a continuous sampling zone. Sampling continues, and one more unit is inspected, and then you check that what is the current value of the cumulative number of non-conforming unit, and then you decide that whether you are going to accept it or you are going to reject it or you continue sampling. Now, two more examples we have, example 7, so that you work out. I have just read it out, it is very simple one, that is the equations for the acceptance and rejection lines for a sequential sampling plan we have already derived. So, suppose these two equations are given for the acceptance and rejection line for the sequential sampling plan. What is the first opportunity to reject? You please solve this problem. What is the first opportunity to accept? Is it okay? So, this is for you. I am giving you this exercise to solve. And what is the solution? That means you will get, I am just giving the answer. The first opportunity to reject is on the second item inspected, and the first opportunity to accept is on the 16th item inspected. Is it okay? So, this is the solution, and then you move to example 8. So, this example 8 is just I will read it out, and all the steps are given over here. But this is the case where it is a single specification limit case, right? Your purpose is you will be using a variable sampling plan to control the process average, and the standard deviation is unknown. So, we have already explained the procedure. So, just I will read it out. Unleaded gasoline must meet certain federal standards. The octane number for a particular brand must be at least 89. The standard deviation of the octane number is estimated to be 4. That means the case of the lower specification limit case. It is preferred to accept shipments for which the average octane number is 94 about 95% of the time. That means your basic purpose is to control the process average. Also, for those shipments that have an average octane number of 86 considered to be very low, the probability of acceptance is desired to be 0.15. Find the parameters of a variable sampling plan. So, you know what is the value of the lower specification limit, that is 89. Sigma hat, it is given, it is 4. X1 bar is 94, alpha is 0.05, X2 bar is 0.86, beta is 0.95. So, what do you try to do? That means you form the the t distribution, and you refer to that particular curve, and you will find that the sample size is approximately 4, and the t value corresponding the lower tail area of 0.05 with 3 degrees of freedom is minus 2.353. You refer to the t distribution table. The plan works as follows: a random sample of size 4 is chosen, and the sample mean and the standard deviation are computed. The following statistics is computed. That means x1 bar minus 94 divided by s, that is the sample standard deviation, divided by root over n. That means here the sample size is 4, n equals to 4. If t is less than minus 2.353, the lot is rejected, otherwise lot is accepted. So, these are the 8 problems we have discussed in this session.